Hello, it is I, Mr. Burkhardt, with another video to show you how to do the work. This is from the workbook. This is your pre-lab for the lab with the hockey puck and all that. All right, so the students decide, okay, the toy company claims to develop two toy cars, which they call A and B. How clever. The average speed of each car is identical. Each group of students is given two toy cars, one of each model, meter sticks and stopwatches, and asked to test the toy company's. Well, that would be fun. Yeah, that's not going to happen. The students decide that they need to collect distance and time data for each car to test the company's claim. The students design a procedure, cross out any extraneous steps, and order the remaining procedural steps. Gather equipment, and okay, let's see. So what are we going to do? We're going to probably make a data table first. We're going to measure, let's see, we need to have a path next. And we're going to turn the car on. And then we're going to measure the time. And then we're going to repeat. Alright, so that is my idea. If you have a different idea, you should argue with me about it, because that would be amazing. I would love that. Alright, given the data collected by the students, what conclusions should the students make about the hypothesis that the two cars have the same speed? Do they have the same average speed? They have different average speeds. Alright, so here is A, 0.45, 0.46, 0.42, 0.43, 0.74, 0.44. Okay, that's weird. Here, 0.54, 0.5, 0.5, 0.5, 0.2, 0.5. All right, so lab group number 5 are messing up. Let's just say that. I would say that based on the data, that lab group number 5's data is wonky, and that actually, if we recalculated these averages, we might find that they're not exactly the same. It looks like this car seems to be a little bit slower than this car. I mean, they're both pretty close to 0.5, but this car clearly seems to be faster than this car. And that's what I would say here. I would say, well, group 5's data looks bad. And if we throw it out, the averages would not be the same. All right. So they decide they want to test the claim as constant. So it's constant. How does this procedure need to be modified to verify that it's actually constant? Angela thinks they should use a motion sensor to collect speed versus data. If the graph is horizontal with a zero slope, that would be constant. Blake thinks they should use Photogate's position at the beginning end of the 2-meter stick, the length, and divide this by the time to get the instantaneous speed. All right, so we're going to go with Angela, because if Angela, so we haven't used a motion sensor. Well, that is a great idea. I think that's what I'm going to do next week. The motion sensor would plot out, that would be the position graph, and the speed graph would do exactly what Angela said. It would look like that, right? So that's perfect. So the problem with Blake's is, right, we get a data point here, then we get a data point here, but we don't know what happened in between the two data points, right? And that's what we want to know. We want to know if it's the same all the time, not just grabbing two grabs, right, and then calculating an average, which is fine. You could calculate an average that way, but it's not telling you what's happening in between the two data points. All right, thank you. That was quick.